Brilliant. Always a pleasure to come and chat, and I'm sorry I didn't get the very first session, but certainly enjoyed what I've heard thus far. So I'm going to, or Bridget's asked me to talk about a study that actually she's a co-investigator on. So I work at Auckland University as an injury epidemiologist. Thank you. But I started life off as a paediatric nurse, and I was a trauma coordinator at Starship, and have been involved in EMST courses and stuff. So I've sort of dabbled in trauma for a very long time, as evidenced by my hair colour. So this study was HRC funded, Health Research Council of New Zealand funded. As always, had a cast of thousands, but Ian Civil was on there, who's heads up the Major Trauma Network. Bridget, as I mentioned, colleagues in the US and colleagues down in Otago University. And on the study advisory group, we've had representation from emergency medicine specialists, coroner, ambulance, National Ambulance Sector Office, etc., etc. So, as you know, as well as anybody, that about 1,800 people die from trauma in New Zealand each year, and about a further 2,000 are admitted to hospital with major trauma. And it's estimated that those costs are about $10 billion New Zealand annually, including all the societal costs associated with that. And as you know, timely presentation to hospital has a very positive impact on those serious trauma cases and can improve survival by up to 25%. Around 65% of injury deaths in New Zealand, and a study that was done in Southland, was suggested to occur before they got to hospital. That same review found that 45% of those cases had survivable or potentially survivable injuries, and I'll talk a little bit more about how that survivability was measured. And we see variation in DHBs around fatal injury rates. So the highest being in Tairāwhiti, 80 fatal injuries per 100,000, and the lowest being in Capital and Coast. So that might suggest something. Obviously, it suggests a couple of things. It may be about access to advanced level hospital care or trauma care. It might also be, of course, about the mechanisms of injuries in those places that are more rural and more high speed and more likely to result in serious injury. So a few things can be going on there. So what we wanted to look at was opportunities to improve survival from serious injury in the pre-hospital phase. We had a number of different objectives that we wanted to achieve, and I'll go through each of those. The study was funded over 3 years, and in the first phase we were looking at survivability. The next phase we were looking at theoretical access to advanced level hospital care, and in the final phase we sort of drew it all together. So the first thing we had to do was identify who their patients were. So anybody who's discharged from hospital or who dies, we collect a minimum data set on in New Zealand. So we were able to look at the mortality collection for people who'd had an injury, a death that was related to injury over a 5-year period, and that was almost 9,500. And then we were able to look at what amongst those happened pre-hospital. And there was about 74% of them. And I should note that this is all injuries, so it includes our appallingly high suicide rate within there, of which there's 500 odd a year. So of course if we were just looking at trauma related, it would be lower than that, but this is all deaths. So when we look at the differences by rates and pre-hospital fatalities, where I've highlighted that in red, by age, the rates are significantly higher in younger people, or younger 16 to 24-year-olds, and our older population. That 16 to 24-year-old population, some of that is a result of the high, suicide deaths in that age range, and another driver, of course, is road traffic injuries, which you get to see too often. And the older age group, obviously some of that is comorbidities and things that mean those people are more likely to succumb to their injuries. Differences by gender, we all know men are dangerous and have more injuries than us safer females. And then when we look by ethnicity, Māori have statistically significantly higher rates of fatal injury than their non-Māori counterparts, and there's lots of factors that impact on why that is. So I'm not going to spend too long on this slide, but the blue bars are the deaths that happen pre-hospital, and the orange bars are the deaths that happen in hospital, injury deaths. And the falls there are the one that looks pretty different to everything else, and that's probably more like to the predominance of, although of older people in that age group of fall-related deaths. When we look at trauma by region, really the interesting thing there is this is their domicile region, so where they normally live. And we can see for the tourists, obviously a lot of those deaths are happening pre-hospital rather than in hospital, and that in part reflects their overrepresentation in our road trauma deaths. So then the next bit that we were looking at is injury severity. So looking at that notion of what proportion of these injuries are survivable or potentially survivable. So in order to be able to do that, this is a theoretical exercise, but we need a post-mortem for these people, and we need a post-mortem that has sufficient information that we can actually injury severity score. So in New Zealand, most unexplained deaths result in a coronial inquiry of some sort or other, and injuries usually fall into this. Although with post-mortems, we've noticed a bit of a decline in the number of people having post-mortems in the 5 years that we looked at this data, and that's the same that's happening in Australia. People can refuse to have, a post-mortem of a family member if they want, and obviously as we get more advanced imaging, quite often in Australia, for example, if they've had a CT, they won't necessarily have, or they've had advanced imaging, they won't necessarily have a post-mortem. But when we injury severity score, we got the post-mortems. Some of them, of course, you had a very decomposed body, so we can't injury severity score those because someone is manually extracting the injuries that are listed in the post-mortem. Sometimes we get a leg or a foot, so that's not very useful if we're trying to injury severity score the whole body. So what happens is the body gets divided up into 6 regions. It's based on the abbreviated injury score, and they're allocated a severity for each injury of 1 to 6, and then the 3 highest scored body regions, it's squared, and that gives us injury severity score. So it's a very, it's a crude proxy. It's looking at anatomical injuries. It's not taking into account comorbidities. It doesn't take into account contextual information. As you know, if someone's been trapped and it's taken a long time to get them out, that's going to impact on their survivability. If somebody's car went down the side of a bank and they weren't found for a couple of days, that's going to impact on it. Weather, if there were multiple people trapped. So none of that is accounted in this. It's purely just an estimation of survivability based on their injuries. And then we look at probabilities of survival, and these cut points in the colour over there on the slide are based on international studies. So international studies tell us that if you have an injury severity score of less than 25, that is a theoretically survivable injury, potentially survivable 25 to 49, and non-survivable over 49. So when we looked at that for these cases that we were able to injury severity score, we found that 11% of them were survivable, 28% potentially survivable, and 61% were non-survivable. And so if you think about the survivable and the potentially survivable, that's about 174 lives per year, an estimated societal cost of 730 million per year saving if we use the value of a statistical life, which is about 4.2 million, which is a number that is used for transport deaths. It's called a value of a statistical life, and it's obviously often used in policy and advocacy work when you want to put a sort of a theoretical value on a life that you want to save. So then we looked at it by age group to see which age groups had the most survivable or potentially survivable. And again, not surprisingly, it's the older age groups, but again, that reflects a little bit the flaws with ISS, and that it doesn't account for comorbidities. When we looked at it by ethnicity, Māori had the highest proportions of survivable or potentially survivable injuries. And again, that reflection, some of that is mechanism of injury, some of it is they are potentially more likely to live in rural areas, and we know that outcomes in rural areas might be less favourable for a whole raft of reasons. And in the interest of time, I won't dwell too much on this slide, but really to show in the red on the right-hand side of the table that the largest proportion of non-survivable injuries were transport-related injuries. And as we know, they're often, high velocity, high impact, high transfer of energy in those. And when you look at the ones that had the highest proportion of survivable injuries, again, a slight flaw with ISS, but cutting and piercing. So you may have a penetrating injury of some sort or other to an artery, which is fine if you've got someone there who can apply pressure or put a tourniquet on, but if they can't, obviously things aren't going to go as well. So then we looked at their theoretical distance from advanced level trauma care, and I'll talk a little bit more about that. But you can see there are differences, those who were survivable or potentially survivable that I've highlighted with that red circle seem to be in that 90 to 120 minute theoretical distance from advanced level hospital care. So our findings were consistent with other studies, so 61% of injury deaths occurred pre-hospital, that we could do this injury severity scoring, which is consistent with US studies, and that 28% of trauma deaths were potentially survivable, similar to other US studies, and that a third of road traffic deaths were potentially survivable. So then we got on to the next bit of the study, which is looking at theoretical access to advanced level hospital care. So in this next part of the study, we mapped on a map of New Zealand the location of level 1 and level 2 trauma hospitals. And then we worked with St John and also with the Helicopter Trust to get theoretical times. So we used what's called network analysis, road network analysis, to work out theoretical times from as if you received a call, you went to the scene, you had a bit of average scene time, which we got from St John, and then back to a advanced level hospital care. So we did those calculations that the ambulance travelled at the speed limit. Then we did air ambulance, we got their mean flight times, and we did the air ambulance travel as if it was as the crow flies. So when we did that, this shows the first map, map A, is showing the population density of New Zealand. So as we can see, the population is concentrated around our major cities. And then in the middle graph, so this is road access, road network access to level 1 and level 2 hospitals, and we look at what proportion of the country gets coverage within an hour of that theoretical time. Now, there's a few caveats on this, and the first is that in our modelling, we use the example of the ambulance being at the base, and we know that in contemporary times in a city, you may in fact place ambulances at places where you're going to anticipate there might be need, e.g. near motorways, etc., rather than they won't necessarily be at a base. The second map, map C, is looking at response time with between an hour 45 response time. What proportion of the population land coverage has access within that time? So on the next maps, we did that by air. So again, as you would expect, a little bit more coverage. The middle graph is showing that response within an hour, and that the third graph across is showing access within an hour 45. And you can see the parts of the country that don't receive timely access. Obviously, we do have the Southern Alps running down the spine of the South Island, so that's not surprising. Northland, East Cape, and a few other curious spots where there's not timely access. So this is putting air and land access together on these graphs. So this is looking at combining both air and land. And what we find is that 84% of the population in New Zealand do have access, timely access to advanced level hospital care within 60 minutes, which is encouraging. but 16% do not. And when we look at who doesn't have that theoretical timely access, excuse me, we have the older population, and again, they may be more likely to retire to rural areas. And then we have Māori, again, who are having a poorer access, and that population density is a sort of a Stats New Zealand type measure, but the rural obviously is the lower areas. So there's around 694,000 New Zealanders who don't have timely access to advanced level hospital care. There are disparities in that access by age and ethnicity. And I'll just very quickly go through this next one, was where we put everything together. So we put onto the map of New Zealand where the deaths happened and where the access is. So we found 29% of pre-hospital deaths had a location of injury in a small area mesh block without theoretical timely access. So that's almost a third of those pre-hospital deaths happened in places where there wasn't timely access. And in this next one, I'll just show you this. This is a density plot map, and the little dots, which are difficult for you to see, are where the survivable and potentially survivable deaths happened that didn't have timely access. So it's novel research for New Zealand. It's population-based because we have the deaths for the whole country. It's aligned by methods used by others. It's we think, a good advocacy tool. The National Ambulance Sector Office have been very interested in what we've found to date. It's obviously been timely around the discussions of where the new helicopter bases will be located. And we can use this modelling. We can say, well, if we shift an ambulance base to here, what happens? We're doing a deep dive into those survivable deaths and potentially survivable deaths to see if we can get out some more contextual information to find, for example, they weren't found for 3 days, or we have to see actually what proportion of those that are deemed survivable by ISS, actually potentially may have had that. And I am out of time, so I won't talk about the next study, or would you like me to spend 1 second? Okay, so we've the next study, which we've the same investigator team and the same study advisory group have received funding from the Health Research Council, another 3-year study. And this study is looking at how EMS care impacts on survival to hospital for major trauma cases. So we're looking at survival to the first 24 hours for our survival to hospital, because we know beyond 24 hours there's all sorts of factors that might play an impact on outcome that are beyond what might happen in the pre-hospital phase. So we're looking at time factors, all of the time variables that you guys collect. We're looking at what sort of care gets delivered, who delivers the care, the level of qualification of the person, all those sorts of things, all the things that we think may impact potentially on survival, whether the staging, the method of transport, etc., etc. And again, it's going to be a major trauma cohort, and we've cleverly timed the study, so we're using Wellington Free ambulance data, St John data, and we'll be linking the serious injury cases that are identified by you wonderful folk with the major trauma network data to collect those, link those two data sources together, and then we'll do some predictive modelling using various statistical approaches to see what factors might predict poor or good outcome. So that is me. Any questions?